Hello everyone. In the last session we have started with introduction about microcontroller, the differences between the microprocessor and controller, what are the criteria to select for the microcontroller and the applications of your microcontroller. Let's start this session with the features and the architecture of 8051. Generally 8051 was called as a system on a chip. Why? Along with your CPU, the RAM, ROM and all the I/O were built on a single chip. That is why it was called as a system on a chip. This 8051 microcontroller, it was a 8-bit microcontroller designed by Intel. So 8-bit means the maximum input you can give to the controller is only 8. If it is more than 8, then you have to make them as segment. For example, if your input is 16 bits, then that 16 bit cannot be directly fed into the controller. You have to make them two parts of each 8 bit. So the maximum input you can give is 8 bit. That is why it was called as 8 bit microcontroller. The 8051 is having 4 kilobyte of ROM. So 4K is nothing but 4096 bytes, because 1K is equal to 1024 with respect to processor. Similarly, we have a RAM of 128 bytes. We have the 4 register banks. We have 12 megahertz crystal clock generator. Then we have IO lines, which are 8-bit ports and which are 32-bit bidirectional. We have multiple mode high speed programmable serial port, and we have the byte and bit addressability. Like this, we have the different features of 8051. Coming to the architecture, we have already said that yes, it is consisting of a CPU. We have the two kinds of two kinds of memory. One is RAM and the other one is ROM. We have the IO ports and control logic. This is how internally MIT 8051 looks like. Let's start with the interrupt control. So when we say interrupt, it is like a disturbance which is generated by a program for the service. For example, just think when a class is going on, when the faculty is taking the class about the microcontroller, and one of the student asks for a doubt. When he asks for a doubt, it is like disturbing the class, but he wants his doubt to be clarified. That is what the service which is given, which is supposed to be given by the faculty. Right. So supposed to be given by the faculty, that help is nothing but the service, and that service is given to your program, nothing but to the student, so that it will be interrupted. The class is disturbed in between, but the service is given by the program, nothing but the faculty to the request who has been made. So that is that disturbance, we call it as interrupt. And we have the interrupt control. Here we have two kinds of interrupt. One is software interrupt and the other one is hardware interrupt, which is the one of the block of your 8051. The second one is ROM. This ROM is for your program code. So program is nothing but the set of instructions we need to execute a particular task, and we said that the ROM is of 4K, nothing but 4096. Next we have on chip RAM. So this RAM is of totally 128 byte. Next we have timer 0 and timer 1. We said that it is for 16 bit, right? So they have 16 bit timers and counters. So when we say timer, they are used to generate the delay of a particular, and when it's coming as a counter, it is used to count the external pulses. Next we have CPU. So CPU is nothing but your central processing unit. So this is one which is going to monitor and control all the operations that has to be performed by the microcontroller. So along with this operation, it will be having the registers like A and B. You have program status word, we have the stack pointer, we have a 16-bit program counter, and we have data pointer register. So all these register has been put up in your CPU for your particular functions to be carried out. Next we have the oscillator part. So this oscillator part is nothing but to generate the clock. We have to provide to the 8051, and it has to be decide the baud rate. So baud rate, which is for a serial communication, we need the baud rate. So baud rate is nothing but number of signals per second, we say. So bus control is nothing but the carrying the information between one device to another device. It has to be taken care by your 8051. Next we have the IO ports. So IO ports are nothing but your input output ports. Here we can see that we have the 4 ports P0, P1, P2 and P3, where P0 is used for both address and data, P2 is used for higher order byte address bus, and P3 is multi-directional. The pins which are available in P3 are all multi-directional. Next we have serial port. right? So serial port is nothing but for your serial communication we have. So this serial communication is done by using the pins TXT and RXT. So TXT is for transmission, RXT is for your reception. So when we say about RAM, we said that totally we have 128 bytes, right? So in this 128 bits, they are like totally they are consisting of 32 registers. So that 32 registers is made as 4 banks: bank 0, bank 1, bank 2 and bank 3. Each bank will be having 8 registers. So for example, if you are numbering the registers as R0 to R7, you can say that each bank will be having 8 registers. So totally we are having 4 banks. So bank 0, 1, 2 and 3. Therefore 4 banks into each of 8 register, totally you can have 32, right? So we have totally 32 registers and the overall memory allocated for this is 128 bytes. So this is how the blocks which are considered in your 8051. We said 8051 is a 8-bit microcontroller, nothing but the maximum input you can put it is only 8-bit. If it is more than 8-bit, then you have to make them segments. So we have the interrupt control, so where it can be both software interrupt and hardware interrupt. We have a total memory of 4K ROM, which is for your program. Next we have RAM, where you having totally 4 banks of registers, bank 0 to bank 3, where each bank will be consisting of 8 registers, and so 8 into 4, totally we have 32 registers. We have timer 0 and timer 1, which are 16-bit. When it is like timer mode, it will be used to provide the delay, to generate the delay, and when it is counter mode, it is used to count the external pulses. So bus control to carry the information between the different devices. Next comes IO ports. So totally we have 4 ports: P0, P1, P2 and P3, where this one is multiplexed for address and data. This is for higher order byte address bus. These are the pins available in P3 are multifunctional. So serial port, this is to use for serial communication, this is for transmission, and this is for reception. Oscillator mode to create the clock, which is generally of 12 megahertz, and the heart of your controller is nothing but your central processing unit, which is consisting of the registers, or all the registers are nothing but your accumulator A, and the other registers you can use as B. Then you have PSW, you have a stack pointer, you have a 16-bit program counter and data pointer register. So overall this is the architecture of 8051 and the features of 8051.